everyone. Once again, welcome to our online physics classroom. Hope all of you are fine and safe at home. Children, in the previous session, we have gone through speed and velocity. I hope you might have understood the difference between speed and velocity. So, what do you mean by speed? Yes, speed is total distance traveled by time. And what do you mean by velocity? Velocity is speed along with the direction, and it is obtained by the ratio of total displacement by total time. Okay, and we also discussed about average velocity and average speed. Today, we will discuss about two different types of motion, that is uniform motion and non-uniform motion. I think from the name itself, you might have got an idea of uniform and non-uniform motion. So, through some interesting examples, let's frame or let's understand the concept of uniform and non-uniform motion. Children, let's get started with the session. Children, have you ever noticed the speedometer of your car when it is going through a crowded street? Yeah, it shows different values of speeds every moment. So what type of motion is shown by your car at that moment? At the same time, when your car is traveling along a straight road with the same speed, what is your speedometer reading? What type of motion is shown by your car at that moment? So let's answer to all these questions through some examples. Okay. So let's consider this example. Consider the motion of this boy. Here the boy is initially at this position 0. And this number line represents the distance traveled by the boy in meters. Now, after 1 second, let the boy reach at this position. That means at 10 meter after 1 second. Now, after another 1 second, let the boy be here at 20 meter. Okay. Now, after another 1 second, let the boy be here at 30 meter. After another 1 second, let the boy be here at 40 meter. Okay. Again, after another 1 second, let the boy be here at 50 meter. Like this. So this is the journey of this boy. Let's tabulate this journey here. So here during the first interval, what is the time interval? Yes, 1 second. For that 1 second, what is the distance traveled? 0 to 10. So what is the distance? 10 meter. So 10 meter distance is traveled during the time interval of 1 second. Now, within another 1 second, what is the distance traveled? Distance traveled is from 10 to 20. So what is the total distance? 20 minus 10. Again, it is 10 meter. Again, for another 1 second, what is the distance traveled? 20 to 30. 20 to 30 means what is the distance? Yes, again it is 10. And for another 1 second, what is the distance traveled? 30 to 40. 30 to 40 means again it is 10 meter, and the time interval taken to cover that distance is 1 meter. 1 second. So this is the journey, and I'm not considering this portion because we don't have enough space here. So this is enough. This data is enough. Now, just find out the speed here. What is the speed? Speed, what is the equation or formula to find out speed? Yes, it is distance divided by time. So what is the distance? 10 meter. What is the time? 1 second. So what will be speed? Distance by time. 10 meter per second. That will be the speed here. Again, for the second data, what is the speed? Again, it is 10. For the third case, it is 10. For the fourth case also, it is 10. So, for all the time intervals, the speed is same. And what is that? 10 meter per second. Now here, What is the distance traveled? Distance traveled or distance covered is equal, and the time interval is also equal, isn't it? So the time interval is also equal. So here the object has covered equal distances in equal intervals of time, right? I repeat, here the object has covered equal distances in equal intervals of time. My dear children, this is uniform motion. So what do you mean by uniform motion, or how will you define uniform motion? Uniform motion is a type of motion in which the object covers equal distances in equal time intervals. And what will be the speed of the object in uniform motion? Yes, speed will be constant. The object will be moving with a constant speed when it is in uniform motion. Okay. So once again, let's define uniform motion. What is uniform motion? Uniform motion is a type of motion in which the object covers equal distances in equal time intervals. Okay. Children, now let's consider this case. We have considered the same old boy and we have considered the same old number line which represents the distance covered by the boy in meter. Now initially the boy is at O, not O, actually it is 0, at 0, and after 1 second let the boy be here. That means at 10 meter distance after 1 second. Again, after another 1 second let the boy be here at 30 meter. Okay. Again, after another 1 second let the boy be here at 40 meter. After another 1 second let the boy be here at 70 meter. Okay. Let's tabulate this journey here. So the time interval is same. That is, always the time interval is 1 second. Right? Here the time interval will be same. The time interval will be always 1 second. Now, what is the distance traveled for each time interval? For the first 1 second, what is the distance traveled? 0 to 10, 10 meter. Now, for the next 1 second, what is the distance traveled? It is from 10 to 30. So, what is the total distance? 30 minus 10, that is 20 meter. And for the next 1 second, what is the distance traveled by the boy? 30 to 40, that means 10 meter. Now, for the next 1 second, what is the distance traveled by the boy? It is from 40 to 70. That means the total distance is 70 minus 40, that is 30 meter. Okay. And what is the speed here? See, for the first case, what is the speed? 10 by 1, 10 meter per second. For the next case, speed is 10 by 1, that is 20 by 1, 20 meter per second. And for the third case, again it is 10 by 1, 10. And for the last case, it is 30 by 1, that is 30 meter per second. So here the speed varies during each time interval. And what about the distance traveled here? Yes, the distance traveled is not equal. The object has covered unequal distances, right? Now, what about the time interval in this case? Yes, time interval in this case is again same. What is that? 1 second. So here the time interval is equal, but the distance covered by the object is unequal. That means the object has covered unequal distances in equal time intervals. My dear children, this type of motion is known as non-uniform motion, where the object has covered unequal distances in equal intervals of time. And you must remember this fact, here the time interval is equal, only the distance covered is unequal. So what do you mean by non-uniform motion? Yes, The motion in which object covers unequal distances in equal intervals of time is known as non-uniform motion. And what about the speed of the object when it is in non-uniform motion? Yes, speed is also non-uniform. So the speed of the object is non-uniform, or the speed of the object varies when it is in non-uniform motion. Okay. Now can you give some examples for uniform motion and non-uniform motion? Yes. For uniform motion, what is the best example? Car moving along a straight road with same speed. And for non-uniform motion, what is the best example? Yes, car moving in a crowded street, because sometimes the car need to slow down, the car need to stop, or car need to increase its speed, like that. A person jogging in a park, his motion is non-uniform because his speed is not always the same. Okay. Now you can answer the question that I posed in the beginning of the session. What type of motion is indicated by the speedometer of your car when it is moving along a straight road? Yes, it is not uniform motion. Always the speedometer needle points to the same value at that time. And whenever you are moving in a crowded street, your speedometer needle varies or deflects to different values, showing different speeds at different moment.